This is January 2016, paper 1, and this is question number 12. So we have here, this is a weird looking contraption, and it's called a solar updraft tower. You've never seen one of these before, but that's okay because all of the science is something that you have seen. They're just asking you to apply it to a situation that you might not have seen before. It might make you a little bit uncomfortable, but when you start reading through the questions, you realize you've done all this stuff anyway. So all it's got is some radiation from the sun, paused on this cover. There are some thermal radiation blocks below here, and it turns out visible light is allowed to pass through, and then it traps infrared. So the cover allows visible light to pass through, but traps infrared. Rows of blocks under the cover absorb this thermal radiation. So explain what happens to the air at A just under the covers. So obviously, if there's lots of thermal radiation coming from these blocks and from the sun, the air is going to get hot. Air becomes hot. What happens to air when it gets hot? Well, it expands. When it expands, it rises. So here you could have put becomes less dense. I think some people are going to put the air becomes less dense. What you are not going to say is that the air particles expand, because the particles themselves don't expand. And you're not going to say they become less dense, because particles don't get less dense. You can say the air becomes hot, expands, and rises. That's what they're looking for. Try and focus on just the air here. On the diagram, mark the direction of the air movement over the blocks of the material and through the turbine. So it should start with an arrow over here. It's going to go up here as it rises, so it's going to go over these blocks, through the chimney, and over the turbine. State the name of this effect. Well, it's a movement of air after it's become hot and expanded and so rises. That is a convection current. Complete the energy transfer diagram for an SUT. Well, here it's going to be thermal radiation. What happens to the air after it absorbs thermal radiation? Well, it starts to move. So that's kinetic. And then eventually it's going to turn into electrical. And that'll be our 2 marks. Describe how a SUT can be used to generate electricity. Well, air is going to turn the turbine. Air turns the turbine. And then a turbine turns a generator. Very simple and straightforward for 2 marks. There's just a description. So what's going to happen? The air goes over the turbine. Turbine turns to generator. That should have been an easy one. Suggest why the SUT generates most electricity during daylight hours. Well, the sun provides thermal radiation. So without the sun, no thermal radiation can be absorbed and the air wouldn't get hot. So you could have said here, during the day, there is direct heating from the sun, any equivalent, something like that. Suggest why there are blocks of material that absorb thermal radiation. Now, these are 2 tougher marks to get. So why would those blocks want to absorb the thermal radiation? Well, it's because they want to continually heat. So convection continues at night. You don't want something generating just during the day. If you have those thermal blocks there, they'll absorb the thermal radiation, get hot, and after the sun goes down, they'll give out that thermal radiation, they'll emit it, and warm the air above it, even at night. Suggest an alternative to these blocks that could improve the total energy output. I think the one people would have gone for this one, for 1 mark, would have been paint them black. Something painted black so it absorbs more radiation, or paint the blocks black, or black objects, something like that. Really good one would have been to say to use water tanks. Water is an extremely good absorber of radiation. It absorbs a lot, but then it will also emit a lot as well. And you could have also had something like use solar panels, photovoltaic cells, something like that. But I think most people would have gone for this one because they would have keep absorbing radiation. Okay, and that's question number 12.